In these three problems, we're going to remember that the terms in Pascal's triangle are all combinations of n things taken k at a time. And therefore, we can use those numbers also as values for the binomial coefficients. So first of all, let's quickly write down the first 7 rows of Pascal's triangle, starting at row 0. There we go. In the first case, we are wanting to expand the expression 4x plus 1 to the fourth. Our first term in the binomial we'll consider a, and the second b, so that we are considering an expansion of a binomial a plus b to the fourth. We will take the coefficients from the fourth row, starting the counting at 0, and notice that there will be 5 terms. And so we start with coefficient of 1 times 4x to the fourth times 1 to the 0. Then we will go to 4 times 4x cubed times 1 to the first. I'm sorry, I have a equal in here where I should have a plus. Plus 6 times 4x squared, 1 squared, plus 4 times 4x times 1 cubed, plus 1 times 4x to the 0, 1 to the fourth. The first term in the expansion we actually call the 0th term because the power on the b is 0. So 4 to the fourth is 256. So we get 256x to the fourth as the first term. Four cubed is equal to 64, but we're going to have a 64x to the third factor here, but that gets multiplied by 4, so we get 256x cubed times 1 plus 4x squared gives 16x squared. 16 times 6 is equal to 96. So we get 96x x squared plus 4x times 4 is 16x. And the last term, 1 times 1 times 1, will give us plus 1. So this is the expansion of 4x plus 1 to the fourth. Now in the second problem, we are going to expand x minus y to the sixth. And this is tricky because it's going to result in alternating signs. So I'm going to think about this as x plus the opposite of y, or negative 1y, all raised to the sixth. We know there will be 7 terms. So we start out with 1x to the sixth times the opposite of y to the 0, plus 6 times x to the fifth times the opposite of y to the first, plus 15 times x to the fourth times the opposite of y squared, plus 20x cubed times the opposite of y cubed, plus 15x squared times the opposite of y to the fourth, plus 6x times the opposite of y to the fifth, plus 6x to the 0. The previous one was 6x to the, oh, and I put the parentheses in the wrong place there. Let me just fix that. I just wanted to say 6 times x to the first times the opposite of y to the fifth, and similarly I wanted to say here that the coefficient is 1, x to the 0, the opposite of y to the sixth. So the opposite of y to the 0 is 1. Our first term is x to the sixth. Our second term is going to be a negative, so we'll write subtract 6x to the fifth y. The third one will be a positive, 15x to the fourth y squared. The third one, or the fourth one, will be a negative, 20x cubed y cubed, followed by the positive 15x squared y to the fourth minus 6xy to the fifth plus y to the sixth. 7 terms from the 6th row of Pascal's triangle if you start counting at 0. And our last one in this group is 1 plus the square root of 3 to the 7th. So 1 times 1 to the 7th square root of 3 to the 0 plus 7 times 1 to the 6th square root of 3 to the 1st plus 21 1 to the 5th square root of 3 squared plus 35 1 to the 4th square root of 3 cubed plus 35 1 cubed square root of 3 to the 4th plus 21 1 squared square root of 3 to the 5th plus 7 times 1 to the 1st square root of 3 to the 6th plus 1 times 1 to the 0 square root of 3 to the 7th. And as we simplify that, our first term becomes 1, our second term becomes 7 square root 3, the next one 21 times 3, then 35 times 3 square root 3, then 35 times 3 squared, which is 9, plus 21 times 9 root 3 plus 7 times 27 plus 27 root 3. We can clean that up a little bit more, quite a bit more actually. 1 plus 7 square root 3 plus 63 plus 115 square root 3 plus 35 times 9 equals 315 plus 189 square root 3 plus 7 times 27, which is 189, plus 27 square root 3. Now we're going to collect all of the real terms and all of the rational terms and all of the square root 3 terms, so that the actual answer will be in the form of a binomial. And if I run out of time before this is completed, which I think I will put the answer on Sophia's description for this expansion.